Okay, it's time. So many chairs, not a hot dog in sight. It's a very different world to 2 days ago. Okay, everyone can hear me? All right, okay, excellent. Okay, hello everyone. Welcome to this year's PlayStation sponsored talk. This year we'll be talking about best practices for VR. My name's Lloyd Crawley. I'm an engineer in the developer technology group at Sony Interactive Entertainment. My job there is to work with the engineering teams of game studios, everyone from bedroom indies all the way up to AAA dev studios, to try and help the engineering teams realize their goals from a technical perspective. Regarding VR, me and my team also help communicate to developers the best practices regarding end-user comfort and how to achieve it. So one of the main themes throughout this talk, I'll be explaining from a high-level perspective some common problems that developers face, why they happen, and how you can help mitigate these problems. And I'll be talking about a few other topics as well, okay? So this is the full agenda for today. I'll be talking about my group, how you can become a PlayStation developer, how you use Unity with PlayStation VR, and the main theme of the talk, which is the common problems in VR experiences, okay? So I gave a brief overview of who I am and what I do at SIE. So who are DTG? We are a worldwide group, and we can give you support in your time zone. You don't have to wait for a different team to wake up on another continent to get the help that you need developing your game. For PlayStation-specific help, we have private support open to absolutely everybody, no matter how small. And for PS4 Unity-related support, we have a dedicated forum where the dedicated Unity staff can answer your questions. Okay, so developing for PlayStation VR. Just before I move on, I would like to know who in the audience here at the moment is a licensed PlayStation developer. Raise your hands, please. Okay, some people. So if you'd like to become a developer on our platforms, it's pretty easy and simple to get the ball rolling. Submit your online application via partners.playstation.net. And once you get a response, we do get a lot of applications. There can be a backlog at sometimes. Sometimes it can take a few weeks. Please be patient. People will get back to you. Once you are licensed and you have signed all the necessary NDAs and other legal forms, you can have access to our developer portals online, such as DevNet and TPRNet. To be able to debug and develop PlayStation experiences, you will need a PlayStation 4 Pro dev kit. You will need a retail PlayStation VR headset, and for testing, you will need base PS4 and PS4 Pro test kits. Okay. Also, which is an added bonus of becoming a fully licensed PlayStation developer, you can get a Unity Pro license free of charge. There is also a suite of Unity plugins and sample applications you can download from our developer portal. But if you source any other plugins from anywhere else, let's say the asset store, it is your responsibility to make sure they are compliant with our technical requirements to pass certification and make release. Okay, so you've become a fully licensed PlayStation developer. You've downloaded Unity, and you're really excited, and you want to make, hopefully you want to make VR experiences for PSVR. So how do you get started in Unity to enable VR support? Okay. Over these next few slides, it might seem I'm going through a lot of information, but really these are just a few checkboxes, a few drop-down lists. It only takes about 2 minutes when you actually get around to doing this. So this might seem really obvious, but it can be really frustrating if you don't know. In the Unity editor, in the settings for PS4 development menu, you need to go into the XR settings submenu, and there is a virtual reality supported checkbox. It seems really obvious, but the amount of people who don't know about this checkbox, please tick that checkbox so PSVR is actually supported when you press the play button. Directly underneath that, over the next few slides, I'm going to be talking about some other parameters that you can change in the editor to help with your development experience. So directly under that checkbox, there is an option saying stereo rendering method. So what is that? There are two options I'm going to be talking about in that. So there's a single pass and multi-pass. So with VR, obviously, you have two different images, one for the left eye, one for the right eye, to give this impression of stereoscopy. In single pass, both eyes are rendered in one pass at the same time. For multi-pass, left and right are rendered separately. So what are the drawbacks of each? So choosing single pass usually gives you back a significant amount of time on your main thread and help reduce the rendering time on the render thread. However, post-processing on the single pass requires a little special care. So in those situations, multi-pass can be a benefit. Please look at the Unity documentation for some more details on that, okay? Okay, so, and to set your game's refresh rate target, under resolution and presentation, there is a drop-down list called PlayStation VR Framerate. Please note that the value you choose in this setting is essentially your game's internal frame rate, but it has effects on the reprojection rate too. So for example, if you choose 60 Hertz, your game's frame rate will be going for 60 frames per second, but it will be reprojected all the way up to 120. For 90 Hertz or 120 Hertz, both the internal frame rate of your game and the reprojection frequency will be identical, okay? Even though there's an option that says disabled, that's deprecated, so please don't choose that. Next item is a graphics jobs mode under other settings for rendering. So this allows you to use native or legacy modes. What mode you want to choose will depend on your CPU performance profile. Please use native if your game is render thread bound. On the legacy mode, because the more heavily you are render thread bound, the more likely you're going to see a big performance win by choosing native. Legacy mode is a good mode to start development with because it can help you with your main thread. The feature is more experimental, so if you come across any issues in the native mode, please let us know, okay? Okay. Another important thing is the eye-to-eye distance value. To have an optimal experience for different people, some people want to have a configurable eye-to-eye distance value. Under the Unity editor settings menu is still called PSVR IPD distance. There are three options here. So you have user-defined, system software enforced, and allowing swapping between per user and system default settings during play. The third option is good if you're doing some kind of, like maybe a party VR title and you're passing a headset around and you may need to change some settings to make it 100% comfortable for everybody. Audio is extremely important for an immersive experience in VR. So under the audio backend option in the publishing settings, please choose PSVR Audio Out 3D so that the sound in the headphones connected to the headset is actually enabled. Directly underneath that is virtual speakers drop down. That allows you to set the number of sound sources from around the headset. Or in a very easy way to make set all these, oh, wow. Or an easy way to set all the relevant PSVR settings is via the PlayStation VR Unity example project. That can, oh wait just a second so everyone can close those windows. All right, thank you. Okay, so there is a PlayStation VR Unity example project that you can download from our developer portal. I'll speak about that sample project again a little later on, but if you import the package into your project and then via the PlayStation VR menu that pops up at the top, you will be able to change the settings to get started very easily, okay? So that was a very quick look at some important PS4 VR integration points. Regarding documentation, because everyone needs to check the documentation, you can find the Unity PS4 documentation under Help within the Unity editor, either in Unity Manual, if you install the general editor documentation, or else in Unity Manual PS4 Player, if you're using the online docs as pictured here. It just completely depends on what choice you make during installation of Unity. In either case, the info is under platform-specific PS4 section. All right, so now I'm getting into the main meat of this talk. I'm going to be talking about the VR Consultation to start with. So you're probably wondering, what is the VR Consultation, or VRC for short? VRC is an important and essential mandatory step in your PSVR development process. If you want to be able to actually make submission and have your game out on the market, you must have to pass VRC. So the earlier you plan and submit for a VRC, the better. If your build is playable on a base PS4 test kit without frequent crashing, you can enter the VRC process right away. It is important to allocate time to address any reported issues. So when you're planning the development schedule of your game, please allow some time for fixing any potential problems that might appear in VRC. The whole point of VRC is to ensure that the end user experience is comfortable for everyone, for every title on our brand, okay? So in addition to various PSVR guides and VRC-related documentation that you can read to try and familiarize yourself with common problems, there is also the PlayStation VR Comfort Sample. This comfort sample allows you to change certain parameters like frame rate and latency to see what kind of uncomfortable effects that can cause like a player. It can be used as a tool to train yourself or some of your QA team to be able to catch common mistakes earlier on in development. So PlayStation platforms have the usual kind of tools to help profile CPU and GPU performance, but we also have a VR-specific tool to try and help you with your VR development. It measures things like latency, frame rate, etc. Unfortunately, all of these are covered by NDA, so I can't show any screenshots today, but as soon as you become a licensed developer, you can get hold of those. All right. So I'm going to be talking about a lot of a few common VRC issues over the next few slides that come up during VRC. I'll be going through all of these in order, okay? All right, first of all is incorrect stereo. So you're probably wondering, what is this? What is incorrect stereo? So as I said before, I'm sorry if I'm stating the obvious, but VR, you have a left and a right image to create this stereoscopy and this illusion of presence in the game world. Of course, they differ slightly for the perspective, but if they are inconsistent with each other, what I mean by inconsistent, let's say that you have an object in the middle of your left eye that isn't visible in your right eye. Or let's say that you have different textures on the same object that's visible in two eyes, or you're only applying some post-processing effects to one eye and not to the other. This can create something called retinal rivalry, which can lead to eye strain, which is really unpleasant. As a concrete example, here we have a PlayStation 4 console. It is only visible in the left eye. So this is an example of what I was talking about, where this can lead to a retinal rivalry and eye strain. So how do you detect this when you're developing your game? So a couple of ways. Either through end-user use of your title. They should be able to notice it. Maybe it can be flickering quite a bit, or it might be intermittent. This is another reason why I definitely recommend taking screenshots and videos of your gameplay sessions and reviewing them afterwards. Another way is on PSVR, we have the social screen, where we have a debug view like this, where you can see the left and right eye being output to an external monitor. That way, spectators can also detect any potential issues. However, with that said, not every problem associated with stereoscopy can be analyzed in this way, as is the case with the next issue, which is depth conflict. First of all, just to clear up any possible confusion, what I mean by depth conflict isn't a rendering artifact where you may have a pixel from two objects fighting for the same value and depth buffer causing flickering, but it's, well, I'll show you. So here we have imagine that floating PSVR headset is your player. You have some trees, and behind the trees, you have a dog. If you're a cat person, I apologize. I chose to put a dog in this. So this dog should be occluded by the trees, like so. And I know in some traditional video games that you play on a TV, sometimes they do render an occluded object. It might be something like they might show an enemy through a wall or through an object. You might have some X-ray vision or a power-up or something like that. But because that's on a 2D TV, it's not a problem. In 3D, we have the feeling of stereoscopy. Because that dog is further away than the player, than the trees, this can actually be really uncomfortable to look at. So what can you do about this? Well, the first thing is that normal design principles for traditional video games do not always apply to VR. But from a technical perspective, if you're really adamant about having this in your game, I have a few suggestions. So on the left here, we're always used to seeing objects through transparent objects in the real world. So maybe something behind a tinted window, for example. So one thing that you could do is have any occluding objects become transparent, or you can feather the edges of your occluded object. This will mean that the depth discontinuity between the occluded object and the occluding object isn't as harsh. Two other options are not using the same pixel shading lighting on occluded objects, or you can just render a outline of your occluded object. Of course, these take some time implementing these technical solutions, which is another way, at the design stage, you can try and avoid these issues by thinking about VR and how things in traditional video games can actually make people feel very queasy or uncomfortable in a stereoscopic experience. Okay, so something else that is very heavily affected by this is UI. So traditional video games, we're used to seeing UI all the time. Maybe a target reticule in the center of the screen, like on the left, or some kind of text or a HUD, etc. So what can go wrong here? Again, because this is a stereoscopic image, these things actually have a sense of distance away from the player. So let's say that your game, you have an avatar in your game and you can see your hands. Hands can block certain parts of the UI. This isn't ideal. So what do you do about this? You may be very tempted to do the same thing as the dog, which is just simply render it on top of the occluding object. So this could be a hand or a furniture in your scene or a wall or anything. But as I said, this creates depth conflict. This is actually really, really nasty for your eyes to go through, and some people are more susceptible to it than others. So this is kind of more of a design consideration, but try and avoid UI which is outside of your game world or non-diegetic. Try and make something that is more organic to your game experience. And that sounds quite abstract and very vague, so more solidly, on the left, you can see now that target reticule is projected onto things in your game world. Or even though it's a little contrived, that text is now projected onto the wall. You can make this a bit more natural, depending on your design. It could be graffiti or scratch into a wall or inside a picture frame or something like that. So please try and avoid traditional video game UI for VR. Okay, image quality issues. This is going to seem a wide range of different things, such as flickering, flashing, corruption, and so on, that you also get in traditional video games. But the problem is with particularly aliasing, this can be way, way nastier and more noticeable in a VR experience. I'm going to be talking only about aliasing in depth. So some AA that is really nice for as I was saying, like a TV-based game can be less effective in VR than they are in non-VR games. As such, and given that aliasing artifacts will be very apparent, because even though you think you're standing still, the human body is always moving ever so slightly, and this can make jaggies and crawlies way more noticeable in a VR headset. So I would recommend experimenting with different AA solutions and seeing what gives the best results for your game. Personally, we recommend Unity's built-in MSAA as opposed to post-process options such as FXAA, SMAA, or TAA. But again, test yourselves and see if it's the right solution for your title, okay? Especially specular aliasing is nasty on traditional video games, but in VR it's very, very, very noticeable. And doubling up on what I said earlier about incorrect stereo, if you have really harsh specular aliasing in the left eye, but not so much from the right eye, then that can also create the retinal rivalry. For PSVR, we recommend at least supersampling or MSAA at 1.4 times your output resolution. due to the lens optics that we use. They magnify the center of the screen by 1.4 times. All right, I'm going to be talking about reprojection system now. There is a broad range of issues attached to this, so just bear with me a moment. Okay, let's have a quick recap of reprojection and what it is. Okay, this following description is going to be very verbose, but I will be breaking it down afterwards, so please bear with me. I have to try and read this word for word. The reprojection system will move the latest rendered frame using most recent tracking data to predict head movement, and this is sent to the HMD for display. This can be at a higher frequency than the game's internal frame rate, which will result in a more comfortable experience for the end user when rotating their head. Okay, I did tell you that was verbose, so I'll break that down for you now. So we're in a VR game. Let's assume that the player's head is turning to the left. So the reprojection system calculates the probable difference in rotation at a specified time and moves the image to the right. However, the system will not have image data that lies to the left beyond the bounds of this frame. So what can you do about this black edge? We recommend using mirrored reprojection, and Unity has this enabled as the default setting. So the edge will be fielding like this. So this is where pixels just simply mirrored from the existing frame at the equal distance away. So the reprojection system has a few different synonyms in VR development, including time warping. So now I've explained what reprojection is, I'm going to be talking about some artifacts of it. So first of all, talking about double framing. So what is double framing? How does this relate to reprojection? Go back to the previous example. And again, this is why we recommend not using traditional UI elements like a target reticule in VR experiences. If the player moves their head to the right and the player moves their head to the left, so the image moves to the right, the middle of the screen, the cursor, will also be reprojected to the right. And then when the next frame is rendered, it snaps back to the original center position. So if you have 120 frames a second via reprojection, this can create this kind of effect. So let's take a look at this in action for using a video that was captured within the headset. So as you can see, when the video is played back at this speed, slightly slower than the original, the cursor appears to ghost or appear doubled, but it will be slowing. When it slows down now, you can see that this is actually an optical illusion caused by the persistence of human vision, and the cursor stutters like this. From the social screen, the external debug view I was talking about earlier, the behavior of the cursor may look slightly different because the output is displayed at a much lower rate. So double framing, this occurs by default that reprojection transforms the entire frame image, and the motion of objects between rendered frames is not automatically detected. As we've seen in the videos, objects appear to ghost in the HMD, but stutter on the social screen. And given that it's caused by motion that is not reflected within the reprojection frames, it commonly occurs in these kind of situations. So let's say you have an object mounted to the camera, like a target reticule, or the camera is moved very fast for your game world. Let's say that you're driving a car, or you're flying a spaceship, or you have things move past you in a very fast manner, like some traffic or some debris from an explosion. What can you do about double framing in Unity? Well, thankfully, what I was talking about earlier, the PSVR Unity example project that you can download via our developer portal, it has different subsections demonstrating some great techniques. Handily, one of them explains how to handle the double framing of fixed UI elements, such as a reticule or HUD, using some tricks. I'm not going to go into a technical explanation of what those tricks are right now. When you become a PlayStation developer, please download the example project, take a look. It also has run-throughs how to do many other great techniques for PSVR. Okay, so whilst double framing is a consequence of reprojection, what happens when the reprojection itself seems to suffer from a couple of issues. Okay, so there's two, broadly speaking, types of reprojection issues. There's Hall of Mirrors and Reprojection Edge. Okay, so let's talk about Hall of Mirrors. So now it seems like a standard VR game, moving around, looking at all these floating cubes, and then this happens. You have this infinite hall of mirrored images. So what's happening here? Well, what happened here is that the render thread got blocked by something. And because the render thread got blocked by something, it couldn't feed the reprojection system with up-to-date information. So the reprojection system is simply just replicating itself again and again and again. On other platforms, this can manifest itself as like a small rendered static porthole, and when you look to the left or the right, it's like an infinite sea of black. So yeah, Hall of Mirrors or Hall of Black occurs when reprojection system isn't sent updated render targets, and this can be especially common during loading screens, all right? So there's a lot of file I/O happening in the system. This can sometimes block the render thread. Your player's waiting for the game to start, and all of a sudden they can see these infinite Hall of Mirrors everywhere. Two ways to work around this. You can switch to something we have on PlayStation VR called 2D Cinema Mode, or you can fade to black for a very short time as long as you have some audio in the background, providing that the wait isn't too long. Unity 2018.3 is going to add 2D reprojection. What this means, it's a convenient way in the engine to switch to a 2D cinema mode without having to unload the PlayStation VR device, which normally creates a delay of a few seconds when switching between 2D and VR modes. So this is what happens when the rendering thread stops entirely, but what happens when the delay between rendering and reprojection becomes a little too large? Okay, we get Reprojection Edge. As a quick introduction, this is a screenshot from the PSVR comfort sample I was talking about earlier. As you can see, we have changed the frame rate to 30 Hertz and latency to really high, which, yeah, as I was saying, it will create a very nasty experience for the end user. Just before I start this video, as a quick disclaimer, this video is heavily compressed, so it will be some ugly aliasing, but I'm sure what the Reprojection Edge issue is should be visible. So moving left to right, you can see how the edges of the screens appear to warp. So because the reprojection system is designed to compensate for rotation, the effect is more apparent when the head is shaken more vigorously. Although the artifact can seem really obvious via a view like this, some people are not so sensitive to changes in their peripheral vision. So when they're actually using the headset, they may not actually experience this. However, Reprojection Edge is a must-fix issue, and you're expected to fix it if you want to pass VRC. Again, it's helpful to record video of your gameplay sessions for analysis afterwards to pick up on these kind of issues. What can you do about Reprojection Edge? Caused by these things: low frame rate, high latency, latency irregularity, and incorrect prediction. So just like any other video game, please profile your games early and often to try and avoid this during your development. You'll be able to see when you have bottlenecks in your rendering or anything like that, so earlier the better. Okay. Also, if you're curious about any other potential fixes, you can always log a private ticket for us on our developer portal. The last thing I'm going to be talking about today is something called options long press. So what is options long press? Okay. So this is actually required behavior for all PSVR applications. On the PlayStation controller, there's the options button. If you hold down the options button for a long time, it sends a system signal. All PSVR games are required to respond to this signal, either through a positional reset or orientation preset. So what do I mean? What is an orientation reset? What is a physical position reset? I'm going to be explaining what a physical position reset is over the next few slides. Oh, and just a quick note, on the PlayStation Move controllers, we don't have an options button, but there is a start button. We expect you to do the options long press behavior via the start button on the Move controllers, okay? Okay, so here we have someone playing VR. They're sat on the couch They have the PSVR headset on. In the virtual world, they are actually driving a car. And just to clear up any confusion, this is a right-hand drive car driving on the left-hand side of the road like you do in Britain or Japan, and not on the right side of the road like in Europe and America. But even though they're driving a car, it's just a fantasy. It's a VR fantasy. They're at home on their couch. And then they go to get something to eat, let's say like a hot dog. And they come back and they sit in a different position on the couch and they put on the VR headset. And they're in the passenger seat, but they're still in control of the vehicle. This is really confusing. So via a long hold press of the options button, they can move back to the desired optimal position for your game experience without having to get out of their comfy, warm sofa, okay? All right, so now you understand what the positional reset is and why it's important. You're probably wondering how difficult it is to implement in Unity. So for positional reset, Unity Engine XR Input Tracking Recenter actually handles position and orientation reset. But if you would like help regarding the way you should be able to implement positional-only reset, you can ask Unity support directly via the forums, or if you require guidance from a design perspective, we're happy to talk to you about it, okay? Even if you don't think the design of your game requires this behavior, it does, so it applies to you. Okay, just to wrap up, it's very simple to become a part of the PlayStation ecosystem and become a PlayStation developer. Submit your online application to partners.playstation.net. There are many, once you become a licensed developer, there are many useful resources and tools to use, from documentation to private support from us. It is very easy to use Unity, not just with PlayStation for traditional video games, but also for PlayStation VR. And even though there are many issues you have to keep in mind if you want to try and pass VR Consultation, if you remember what I told you today, you should have less problems. And finally, we have a booth at Unite this year. I don't have a Q&A session at the end, but if you want to talk to us about anything, please come to the booth. It's huge and blue near the main entrance. I don't think it is actually booth 20. I should have changed that. I apologize, but I don't think you'll be able to miss us. And thank you very much for skipping lunch and attending this.